up everybody, it's Math at Home here. Today we're going to have our second lesson, which is going to be about workbook. So we're going to cover page 76 and 77, question 3 only. The corresponding pages are going to be Unit 14, Geometry and Problem Solving. Grab your workbooks and let's get it started. Page 76. Can you remember how many pairs of parallel and perpendicular lines can you count? It is noteworthy to tell you that you could also count the outer lines of the frame. So I'm giving you a couple of minutes to count the pairs of the parallel lines first. Please go for it. Okay, so it's time to answer. Well, in this question, you can count up to 10 pairs of parallel lines, which are going to be the left outer line parallel with the right outer line, the upper outer line parallel with the bottom one, the left side of the rectangle parallel with the right side of it, the bottom side parallel with the upper one, the left side of the triangle parallel with the left outer line of the frame, the top side of the triangle parallel with the top side of the frame, the bottom side of the triangle parallel with the bottom outer line of the frame, the top side of the trapezium parallel with the bottom side of the rectangle, and the left side of the rectangle parallel with the left side of the frame, and the top side of the triangle parallel with the bottom side of the outer line of the frame. And just like that, you can count up to 10 pairs of perpendicular lines in this shape. Question number 1. Classifying 2D shapes. You need a ruler. Join 3 dots on each circle to make these triangles. A. Equilateral. B. Isosceles. C. Scalene. Now, just to be a quick reminder about the definition of these 3 triangles, an equilateral triangle was a triangle with all same sides. An isosceles triangle was a triangle that had 2 equal sides. And a scalene triangle is a triangle with no equal sides. I'll give you 1 minute to draw these triangles. Alright, it's time to do it together. In order to have an equilateral triangle, you need to have all three sides in an equal size. So we are going to have connected dots in a way that they're going to have equal number of dots in between. And as you can see here, between each corner of the triangle, I am jumping over two dots. It means it's going to leave me equal sides of this triangle. For the isosceles triangle, it's enough for you to have two equal sides, which is very simple to draw. By the way, these are my preferred answers. You could have your own. For the scalene triangle, I prefer to have a very narrow yet distorted triangle, something like this, in which no sides are equal. Question number 2. The total length of the sides of a triangle is 18 centimeters. All sides are measured in whole centimeters. One of the short sides is quarter of the length of the longest side. Can the triangle be isosceles? Yes or no? Explain your answer. I'm giving you a couple of minutes to think about it. In an isosceles triangle, can we have the shortest side quarter the size of the longest one? Based on the measurements we have here, think about it. Come up with some random sizes for the sides to see if it matches the question here. Well, after some trial and error, you can come up to the conclusion as yes, because one of the sides could be 2, which means the other side should be 8 in order to make quarter of it, which is equal to 2. So one of the sides could be 2, and the other can be 8 and 8, which makes a total of 18. So our triangle is going to be something like 2 for the bottom side and 8, 8 for the other two sides in order to make them same size so as to have an isosceles triangle. Page 77, question 3. You need a ruler and a mirror. Draw a shape to go in each section of this Carroll diagram. An example has been drawn for you. Okay, so in this part, as you look at the top part of the diagram, the left part is labeled as reflective symmetry, and the right part is labeled as no reflective symmetry. The left part, on the other hand, talks about rotational symmetry and no rotational symmetry. Now, the way you're going to understand this diagram is, for example, imagine we have 4 squares here, the upper left part, the upper right, and the bottom left and right. When we talk about the upper left corner, it means this shape should have reflective symmetry and also rotational symmetry properties. For example, for the shape that is already drawn by the book, it needs to have rotational symmetry only, but no reflective symmetry. Just to be a guide, for example, if we talk about the right bottom corner, it shouldn't have neither rotational symmetry nor reflective symmetry. Now, giving you enough of information in order to how to read, I give you a couple of minutes to think of the shapes that would match on different parts of our diagram and draw them, please. Okay, now for the first part, which I mean the upper left corner, the shape needs to have a reflective symmetry and a rotational symmetry. Well, basically, you don't need to go far. A rectangle would be a good answer. For the bottom left corner, our shape needs to have reflective symmetry. It means it should be foldable, but no rotational symmetry. All right. As you could guess, an isosceles triangle would fit our answer. Now, about the bottom right corner, this shape shouldn't have neither of the symmetries, neither rotational nor reflective. Okay, so I could come up with a five-sided shape that you cannot fold this shape and you cannot rotate it in order to overlay on itself. It means it does not have any kinds of symmetries. So that is going to be a suitable answer for our part. This was the video course for today covering the pages 76 and 77 from our workbook. Watch yourselves out, take good care, and see you next session. Bye bye.